Good afternoon, sir. A very warm welcome to you, sir. And
Thank you, ma'am. Good afternoon.
our next session will be taken by Dr. E. Subhakar Pilli, sir. He is Assistant Professor, MNIT Jaipur, and he will deliver lecture on cloud computing.
Sure. Thank you, ma'am. Yesterday you have introduced, so I think many of them remember me. So we will look at cloud security today. Security aspects applied to cloud computing. As I looked at my research interests, basically looked at applying security and privacy and forensics to every new domain that is coming up. In fact, I started with network forensics, applied little work on network security, and then moved on to forensics. That's where my beginning was. So each time I apply security and then forensics to new areas. So cloud I finished, now IoT I finished. Now slowly looking at blockchain. Yesterday we talked about blockchain security issues. Blockchain forensics is what I am trying to look at. And then Tor is another area that we are meeting at, looking at Tor and Tor security, Tor forensics. Tor you would have heard about, deep web and dark web, right? So maybe you can explore that area also. But presently today's context is on cloud security and cloud forensics. Of course, I will not be delving on cloud forensics, but I had one student finishing a PhD on cloud security and one student finishing on cloud forensics recently. So the student who finished the cloud security 3 years ago, she has published a paper. She has published a book on cloud security with Taylor Francis. So you can look at that book. It was released in December 2021, just last month, right? Maybe 2 weeks ago. So you can look at that book. It is available in Taylor Francis. Most of the content will be from the papers that she has written under my supervision. And they are heavily cited. You can also look at that. The student's name is Dr. Preeti Mishra. So you can look at her recent work also, and then you can try to look at that, right? So we'll try to start with basic introducing cloud to a certain extent, and then slowly moving on to various attacks on cloud computing, right? So let's start. So I start with the topic on cloud security with a little bit of survey on conducted by one organization called Cloud Security Alliance. Cloud Security Alliance conducted a cloud adoption and security in India survey. So that is something which is surprising. Cloud Security Alliance is a US based company, but then they conducted a survey in India, right? And then that is related to cloud security. So you may be surprised. And then this is a broad strategy. Maybe this is a couple of years old. Let us say maybe 2-3 years old, 2019 or something, where they conducted the survey. So you can look at the statistics are a little old, but then by and large, it indicates what it means, right? So 10% are non-users of cloud in various industries. If you look at 62% are active users. So that's there's a lot of people, at least 90% of the people are now active, I would say, right? Using cloud resources in India. And number of years, just add 2-3 years to all of these. So people have already spent 5 to 7 years, definitely, and most of them have spent about 5 years in the cloud, right? So number of applications, they have also would have increased now, but then at least 7 applications are there online, right? Half of the companies, at least they are having 5 to 7 applications in the cloud, right? Basically, private cloud is what everybody is focusing on. There are 3 types of clouds: private cloud, public cloud, and hybrid cloud. Hybrid cloud is a combination of public and private. So in other words, you see that by and large people are wanting to keep it private, right? They're not trusting public cloud. They're not trusting cloud because public cloud is not totally in their control, right? It is in the control of some other organization. But private cloud and part of hybrid cloud is definitely in their control, so they are preferring this part. Wherever the resources are not available to that extent, sometimes they may depend on public cloud whenever there is an overshoot. Otherwise, they will want to keep the data within their network. So that is public cloud, right? Sorry, private cloud. Why people are not fully using these cloud in India? This is a survey specifically for India. As you look at it, lack of industry standards, not cost effective, difficulty integrating with the environment and all. But you see that only security breaches are only two aspects, right? The risk of data loss and risk of security breach. So basically, India is not afraid of the security issues, but it is not having much, work with related to that, right? So that is something that you can look at. If you look at various organizations which are running and which are leading in India, AWS, Azure from Microsoft, Google Cloud, and then you have Indian companies which are basically these three Indian companies are there. One is NetMagic, one is Control S, and one is Tata Communication InstaCompute. InstaCompute is the cloud, Control S, CTRL, that is the Control S, NetMagic. So NetMagic is having a bigger share, and then there are other companies. So whenever you look at an Indian company, if you want to look at in cloud, you can look at Indian company called. And these are the other major attacks which are happening in India: data breach, data loss, insider threat, malware injection, hijacking of attacks, denial of service attacks, insufficient due diligence, and data in transit hacking.
Sorry for the interruption, sir. Actually, it is displaying the first slide only.
Oh, sorry. It's not moving, is it?
It's just the first slide.
Yeah. Sorry. You should have told me earlier. Yeah. This one you have seen?
Again, it is first slide.
This is the only first slide.
First slide.
So please.
Shall I share the complete screen then? Let's see what happens. Are you able to see the slide now?
Yeah.
Yeah.
Right.
Okay, sorry. Anyway, so this is the active users that I was talking about, and these were potential users 3 years ago. So hopefully these all have become users now, right? So that is the first slide that I talked about. Cloud Security Alliance is a US-based company, but they are doing a survey report in India on cloud security, right? So these are the number of years that the cloud has spent. So now you can add some 3 years because the report is some 3 years old, right? So you can add like roughly more than 4 years. A lot of people have spent in the cloud, right? Similarly, the number of applications also would have increased further, but at least there are 5 to 7 applications in the cloud. Mostly 50% of the organizations have at least 5 to 7 applications. In fact, more than 10 applications, they are 25% of them have in the cloud environment, right? So the cloud deployment, people will prefer private cloud, and the hybrid cloud is a combination of public and private is hybrid. So mostly by and large, people are not trusting public cloud because the data or the virtual machines that are created are not in the control of this system. So that is where you try to look at private cloud. You can set up private cloud environments. There are many private cloud environments. Why are people not adopting cloud? So there are many reasons, but the security related reasons are only two. That is risk of data loss and risk of security breach. So that is the only difference here. But the other risks are different reasons. Only security are only two reasons. If you look at market dominance, there are many companies which are there, which are providing cloud services in India. But if you look at Indian companies, there are at least 3 Indian companies like NetMagic, Control S, and Tata Communications. The cloud service is called InstaCompute under Tata Communications. So the good market share, as you see. But then, of course, the bigger players are there, which are, and then, of course, some companies may be using multiple products. So hence, this total is crossing more than 100, right? So you have AWS, Azure, Google, but NetMagic is one prominent Indian company. The attack and data loss concerns, which are basically the security concerns: data breach, data loss, insider threat, malware injection, hijack of attacks, denial of service attacks, insufficient due diligence, and data in transit hacking. So variety of attacks, and the companies which are facing this, the companies may be facing different, many companies may be facing many of these attacks, and hence this is also not totaling 100% in that sense. So how many of the companies, let us say there are 1,000 companies who are interviewed, about 79% of the companies have this data breach problem like that, right? That's the kind of graphic that you can look at. One of the things that I would like to encourage you is, now when you looked at private cloud, what does it mean? Private cloud is you can set up the cloud in your own environment. Now it may be a little challenging because you will need investment of something like 7 to 8 lakhs if you want to set up a cloud, a simple bare minimum cloud. Of course, a very good cloud, you will need at least 70, 80 lakhs, right? But a bare minimum cloud you can set up in 7, 8 lakhs. And of course, on good machines, if you can get i7 desktops with 16 GB RAM, of course, many systems may not have 16 GB RAM, they may have 4 GB RAM. You can increase them to 16 GB, and of course, you may have to do a little bit of investment from your own pocket. But you can do that, and you can, within a lab setup, you can set up a cloud environment. That's what I did. In fact, my first exposure to cloud was with Eucalyptus in 2011. Where we started setting up Eucalyptus. Of course, now Eucalyptus is taken over by HP Helium.
मतलब मैम मेडिकल और ईएल को हम क्लब कर सकते हैं.
Yeah. So Eucalyptus is basically one of the first private cloud software that was there. You could set up on your own. There was also Open Nebula was also there. You could use that. CloudStack has recently come, but now the more standard version is OpenStack. So after Eucalyptus 2015 onwards, as I look at, we have set up OpenStack and we have started using OpenStack. So there are hypervisors. I will explain what a hypervisor is. So you would have used VMware hypervisor, or another popular hypervisor is VirtualBox. VirtualBox is a hypervisor where you could use where that VirtualBox is the basis, and then you can actually look at that. So that VirtualBox facilitates creation of 2 virtual machines or more virtual machines on the system. Maybe you would have used VirtualBox on Windows. On Windows, you would have set up Ubuntu. Or if your base operating system was Ubuntu, you would have installed VirtualBox or VMware. On top of that, you would have installed Windows or some other RHEL or Fedora, or different kinds of combinations are possible, right? So that same thing is possible with Zen and KVM. They are more robust. These things. VMware is proprietary. Zen and KVM are open source, and KVM comes inbuilt with Red Hat Enterprise Linux, and of course they can also very easily be set up using Ubuntu, right? VMware will work with Windows. This thing, and Zen and KVM will work with Linux environments as well. So why I'm spending more time on these tools is this is where your research starts. If you really want to do something on cloud security, right, you need to set up, because cloud security, you cannot work on Cloud SIM. Cloud SIM, you may have heard of Cloud SIM as a software for simulating cloud environments, but then that is mostly used for resource management or energy efficiency. Some of these things can be done, right, on Cloud SIM, but you cannot simulate or emulate attacks on Cloud SIM. So the best thing that you have to do is, maybe you will not be able to set up OpenStack or Eucalyptus, but at least you should be able to work with Zen and KVM. VMware is proprietary, so you can't make any changes for research purposes. So hence that becomes, but then you can work with Zen and KVM, and it's definitely easy to work and coordinate with that, right? So that part is there. So please set up, it's not very difficult. You can download KVM or Zen, and you can look at what are the kind of things that happen, because finally what actually happens in the cloud, if you look at, after some time I will share that the hypervisor is the main heart of cloud computing. Now cloud, as we look at, is also a kind of a network, because it involves systems, it involves switches, and it involves storage. So you connect all of them, and then finally it becomes what is a network only. So security on cloud becomes a network security. So if I want to differentiate between cloud security and network security, the only difference that is there is this virtualization. So we'll come to that and we'll try to understand. These are some companies which you can look at if you really get hands-on on cloud. These are companies which may be looking to employ you, at least starting from this virtualization layer. There are some virtual iron that I talked about, VirtualBox next level, VMware, Zen, Citrix, Zen Server is also there. Zen is there, Zen Server is there, Hyper-V, Windows, KVM, and vSphere from VMware. And then you have Parallels, you have also VMware software, right? Cloud, you have CloudStack, then Cloud.com, Elastic Stack, Eucalyptus, Flexient, OpenStack, VMware Cloud, vCloud, right? Then you have 3 types of services where you are there. Infrastructure as a service. This is hardware or storage or some of these things. Those things are there. These are infrastructure as a service. Then this is platform as a service. Azure, Force.com, Google. These are platform as a service. Then you have software as a service, where you can get some softwares which can be provided as a service. We'll try to explain that shortly. Then you have cloud management, different companies, cloud broker platform, and marketplace. Slightly, if you want to see in a bigger sense, I will share the slides with Dr. Dali Shukla, so you can go through these slides. Maybe today evening after my lecture, I will send the slides so that you can take it further, right? So that is something that you can. So these slides, these companies that are working on cloud environment, you can try to look at. These are public clouds, as I mentioned, Google Cloud and Microsoft Azure, Amazon Web Services, IBM Bluemix, Salesforce, and Rackspace. These are infrastructure as a service companies. These are various companies which can also give you infrastructure and platform as well, right? So these are our Desi providers like NetMagic, as I talked about, and Control-S and Tata Communications, InstaCompute. These are the cloud service providers in India. Now, if you ask me what is a cloud, cloud looks something like this. So you have physical infrastructure which consists of servers or workstations. You have network elements and you have storage elements. So compute in the sense there are servers or processors, multi-core processors which are there, servers, workstations. Then you have some networking elements. Then you have storage. Now, when they are virtualized, right, you get what is called virtual machines. You have what are called virtual storage and virtual network, right? So these are virtual infrastructure. The physical infrastructure is virtualized. And on top of these virtualized software, you set up some applications and some operating systems. You can multiple operating systems on top of that. So this becomes a virtual network, right? Virtual system. And on top of that, when you put the cloud management software, it becomes what is called cloud. So this is how a data center looks like. Maybe you would have heard about the word data center. Data center is, somebody wants to ask something? Okay, maybe by mistake, right? So there is something which is called a data center. You can just see the size of, maybe you can look at this individual standing here. So you can estimate the height of this. So these are all servers on one side, and these are all storage devices on one side, and there are cables which are connecting them, running on these rack, and then they are connected one on top of the other like this. So they are connected to all. So all these are servers, all these are storage devices. So this becomes a network which is connecting all of them. So storage, network, and compute, these are the 3 main aspects of a data center. Now this physical data center, this is how it looks like, right? If this is virtualized, okay, it becomes a virtual data center, right? So these are the classic elements of a data center. You have servers, which will have the processing element or the compute elements. So that's what we call it, compute. The compute elements are the servers. Then you have the storage. Then you have the network. Then you have obviously operating system, DBMS, and applications which are there. So this becomes the classic data center. Now, virtualization, what can happen is you can do it at the compute level, you can do it at the storage level, and at the network level. Now, what is virtualization? If I explain in simple terms, virtualization is where you had used VMware or VirtualBox. Now, what did it facilitate? Earlier, one computer system means one operating system, right? Later, people came up with a dual partition system. One system, you can install 2 operating systems, one Windows and one Ubuntu. But at a given instance of time, either Windows will run or Ubuntu will run. You cannot run both at the same time. What virtualization facilitated is you had an operating system, on top of that you had the virtualization software, on top of that you can have one more operating system. So two operating systems are running at the same time. So on Windows operating system, Ubuntu became like MS Office or Word. Word is one application which I open. Like that I open Ubuntu as another application, right? An operating system is running as an application. That is what is called the virtual machine. The physical machine is running as an application, and hence it becomes a virtual machine. So that's what it is. Now, how do you virtualize compute? Right? Compute means processors. How do you virtualize a processor? But as long as the processor was unicore, like Pentium 4 or Pentium 3, it was a unicore processor, only one core in the processor. So how can it be virtualized? At a given instance, only one core is used. But today, advantage is we have multi-core processors. Now, when you talk about multi-core processors, more cores. So more cores means you have, let us say, sometimes 10 cores or 12 cores in one. Like i7 has 4 cores. i7 processor has 4 cores. So what you can do, you can run 4 operating systems and you can give 1 core to each virtual machine, right? So that is the wonderful aspect that has happened. Similarly, network, you can create virtual LANs, VLANs. One LAN is there, but now you can create VLANs. Using the same switch, you can run multiple networks. So that is VLANs. Similarly, then you have storage. You have 10 TB storage, let us say, or 1 TB storage. You can divide it into, or 10 TB storage can be divided into 10 1 TB storages. Logically, you can divide. It's a big device, but logically you divide it and give 1 TB to one virtual machine. Like that, you can supply 1 TB to 10 virtual machines. Instead of 10 TB given to one physical machine, you are giving 10 1 TB storage to 10 different virtual machines. So that is what is virtualization. So what I do, storage I virtualize. Instead of one whole big hard disk, I divide into logical volumes like this. Network, I divide to virtual network. Cores, I divide into multiple CPU cores. Then I can run applications like that. So that is virtualized data center. Now, as I look at it, the classic data center is virtualized. First, I virtualize network, compute, then I virtualize storage, then I virtualize network. So it becomes a virtualized data center. Now, virtualized data center with cloud services becomes cloud. So many times we think cloud is something very new, but no, cloud is very simple. So this is what is cloud, right? So cloud basically builds on virtualization. What is virtualization doing? It's a technique of masking and abstracting the physical compute hardware. Physical compute hardware, CPU, network interface card or the Ethernet card, the memory, that is a RAM, and the hard disk, that is a secondary storage. So these, you could run only one operating system earlier. Now what has happened? You are abstracting and then enabling multiple operating systems to run concurrently on a single machine. So there is one machine, but you are running 3 virtual machines, and each of them have got their own cores, own Ethernet card, or that is a virtual Ethernet card, virtual RAM, and virtual hard disk, right? So these are the things which are provided, and virtualization layer is what is facilitating it. That virtualization layer is called hypervisor, right? That VMware or VirtualBox or KVM or Xen is said to be hypervisor. Before hypervisor, this was a situation. These 4 could run only one operating system. Now they can run multiple operating systems. In fact, this hypervisor is actually acting as a operating system now, right? It becomes it runs multiple operating system. So before virtualization, it was like this, but after virtualization, you have these things, right? So run multiple virtual machines. Now the hypervisor, this is how the hypervisor looks like. It is a software that allows multiple operating systems to run. That virtualization layer is said to be the hypervisor. Now, hypervisor is also of 2 types. One hypervisor is what is called bare metal hypervisor, and the other is called hosted hypervisor. When you look at a bare metal hypervisor, it is directly on the hardware. So hardware, if you want to interact, the hypervisor must directly interact with the hardware. So what will it become? It will become an operating system. So this is a bare metal hypervisor is also an operating system. And then it works like this. But then a hosted hypervisor is sitting on an operating system. There's an operating system, some applications are running, but you have a hypervisor. On top of that, you create virtual machine. There are some operating system. On top of that operating system, there are applications. So this is hosted hypervisor. Now, now that we understood what is hypervisor and all of these, we'll try to understand what is a cloud kind of a model. This is an OpenStack model of cloud. Maybe let me show you a slightly bigger diagram. Yes, hopefully you are able to see this diagram. So now this is what is a cloud. How does a cloud look like? This is how it looks like, right? We discussed what is a virtual machine. Virtual machine sits here, right? Hypervisor sits here. On top of the hypervisor, you have virtual machines, right? So when I want to create a cloud, I have to create a network like this. Okay, there are users which are connecting from outside. They're connecting through the internet, and they connect to these server called the networking server. There are two workstations or two servers which are needed. One is controller server, physical server. The second one is a networking server. Then later you have different machines which are called compute servers, right? Compute server 1, compute server 2, and so on. Let us say there are 10 machines under your disposal, and now you want to set up a cloud, right? So you will need one controller, one networking server, and 8 compute servers. Let us say you have only 4 machines. Then you have this kind of a mechanism. If you have 6, so one controller, one networking, and 4 compute servers you can set up. So these 4 compute servers will be on a network called tenant network and connect to the networking server. They are also on another network called management network, and they connect to both controller server and the networking server. So there are 2 separate networks called tenant network and management network, and a third network is there, which is the external network. So this is the cloud office, and this is the outside world. This is inside the cloud office, 2 networks are running. Outside the network, there is one network running which is connecting to the outside world, and users are connecting. So you may have a question why these 2 networks are separate, right? Why these 2 networks are separate? Because here you see these are tenant networks. Tenant networks means they are connecting to the compute servers where tenants are there. Tenants are setting up their networks, and their network, they are connected only to the networking server. But then there are also another network called management network. Management network, they are connecting to all the servers, including the controllers. The controller server is on the management network, but not on the tenant network. That is the only difference between the management network and the tenant network. Why? So the reason, if you understand, of course, it would have been good if it was face-to-face. We could have engaged and talked and discussed. But here, let us try to understand. Here you have a tenant network. Let us say this office, this whole cloud office, this box we talk about, the cloud office belongs to NetMagic. And NetMagic is providing services for Flipkart. So Flipkart has set up some tenant network here, right? And they are running their Flipkart software. So when you are wanting to connect to Flipkart software, you are typing flipkart.com, it is bringing you to NetMagic, and from NetMagic, it is bringing you to flipkart.com. Now, as a normal user, not as a cloud user, you are not connecting to NetMagic, you are connecting to Flipkart. When you are connecting to Flipkart, Flipkart is also sending responses. So you should be on this network only. So you should go like this, authenticate yourself here, go on to the tenant network, go on to this and all. Because if you go on to the management network, then you can try to go into what is called the control server. So because of that reason, because the internet communication from the outside world happens, right? So I should not be on the management network. That's why they separated and kept another separate management network. So this is something which we try to set up in our institution, MNIT also. And of course, resources are a problem everywhere. So here also we struggled, but then yes, we had to invest. I had to spend some money from my pocket. I spent some, what you called, for the RAM I spent, for the hard disk so not the hard disk, for the Ethernet cards I spent extra money, and we could get that finally, and we could set up something. Of course, it was not fully functional, but we could do it at the virtualization level and all that, and then we could go ahead. So these are different attacks numbers that are mentioned here. So as you look at it, there are some attacks which can happen from virtual machine to virtual machine on the same compute server, virtual machine to virtual machine attack. Virtual machine to DOM0 attack. So we will try to understand what is DOM0. DOM0 is a kind of in Zen. This model is built on OpenStack, running on Zen architecture, Zen hypervisor. So Zen hypervisor, whenever it creates any hypervisors on a system, it creates a default hypervisor, like a default constructor. Maybe you have studied in object-oriented programming, default constructor. Whenever the constructor is called, before that a default constructor is created. So this default constructor, like that, there's a default virtual machine. So this default virtual machine is created. So you can compromise the default virtual machine also, because there is an interaction between these. But the default virtual machine actually has the information about all the virtual machines that are running. So there's a very powerful virtual machine called DOM0. So DOM0 can be compromised. A virtual machine can be compromised. A virtual machine can compromise domain 0. A virtual machine can compromise another virtual machine. Is a different kind of attack from one. Then you have 4, you can compromise hypervisor. If a virtual machine is compromised, hypervisor can be compromised, or the VMM can be compromised. 5, from one physical machine, you can compromise another physical machine, though the line is drawn like this, but actually the communication will go like this. This tenant will talk to the hypervisor will talk to the hardware will talk to the Ethernet, then it goes on to the tenant network, comes here, the Ethernet will talk to the hardware, then the hardware will talk to VMM. From the VMM, the attack will come to VM2. Though there is no line like this. The path is through this, and the path is through this, right? That is how this has to happen. So that is something that we can look at. And also, that is the 5th attack. The 6th attack is an inside controller server. That means the administrator. The administrator is attacking a DOM0, right? So that's an insider attack, it's called. So then you have 7. DOM0 is compromising other hypervisors. Virtual machine machine monitor, or the hypervisor, has been compromised. So it is compromising other virtual machines, right? Hardware is attacking. Then there is a hypervisor is attacking a virtual machine. And lastly, 11 is there's an outside network which is attacking a virtual machine, right? Compromising from there. So VM co-located attack is called a cross VM side channel attack. We will see some of these attacks in detail. So the example is a cross VM side channel attack. VM to VMM host attack, it's called a VM escape attack. We will see all these attacks, so please don't worry about it. Just mentioning those lines. We can look at that man in the middle attack, and then malicious insider attack, leakage due to non-isolation, low-level attacks such as DMA attack, and then information stealing or denial of service attack, that is 11. So these are the attacks on cloud environment. This is the taken from the paper by Dr. Pilli Mishra and myself. So these are the kind of attacks, and slightly, if I show you at a bigger level, this is the diagram which is showing at a big different level. So you see at the cloud virtual machine, there are some attacks. At the cloud, at the virtual machine monitor or the hypervisor, there are some attacks. At hardware level, there are some attacks. At the storage level, there are some attacks. At the network level, there are some attacks. These are security attacks, and most of the papers are published in 2017, 18, of course in 19 also. A lot of papers on cloud security have been published, and similar, all these attacks have been described in detail, not only in Preeti's paper, but then in so many others papers are also there which talk about various types of attacks. So these are 5 major layers that we talk about. So definitely we look at different attacks first on the virtual network. So we start with the virtual network layer. So the virtual network layer, we start with these kind of attacks. So slowly we'll go up and finally reach virtual machine attacks, right? So for the first is virtual network attacks. So man in the middle attack, traffic sniffing, spoofing, all these are explained in detail. So what is man in the middle attack? So an adversary may sit between 2 virtual machines and may try to sift the packets passing through it when the VM is migrated or when VMs communicate with each other. Now, what is VM migration? You may be surprised. There is this concept that 2 servers are running, and 2 servers are running 10 virtual machines, whereas the capability is to run 50 virtual machines. Why should I run these 10 virtual machines and 10 virtual machines here when I can run 50 virtual machines here? So I should shift these, I should migrate these 10 virtual machines here. So while these virtual machines are alive, they are all executing, they are all running, what you do is you take a snapshot of these 10 virtual machines and copy the 10 virtual machines here. They are still running, but these 10 virtual machines have copied here. There is a copy of it which is taken and migrated. 20 virtual machines here. The other 10 are also started, and slowly they are shut down. Now the traffic that was coming here now will slowly go here. So whatever traffic was there while this network was shifted is not executed but stored somewhere. All those instructions, all the requests are stored somewhere. When this virtual machine starts on the other side, these instructions are captured and put in the traffic that is coming in the priority. So first these machines will take care of this traffic, then slowly it will take care of the remaining traffic. So finally, that is something which you can migrate a virtual machine. Live virtual machine migration is possible. These are some wonderful concepts which people are doing, and it's possible to do it. There, while these things are happening, people can sniff, people can find out what virtual machines are going, what is the content that is there, what is happening, and then you can also modify, and you can actually try to become the person. Man in the middle attack is when two people are interacting, you go in between and you actually throw away the other fellow. You both start interacting as if you are the main, the source or the destination, right? So that's how it is. We have traffic spoofing is another attack. All VMs on the same network are open to attacks and compromise from other VMs present on the same network. So a malicious user on one VM can perform IP spoofing, in which attack traffic is generated on behalf of legitimate tenant user and sent to destination VM. So, malicious user can perform IP spoofing. So you can generate IP traffic on some other place and send it to a destination VM. The destination VM will get affected, but nobody knows from where the traffic came. Or you can make a target virtual machine and focus your target, but the replies are going to somewhere else. The responses are not coming, so the system is waiting. So you can do a lot of such aspects of this because there is no verification. You can do port scanning to find out which ports are available. These are kind of network attacks which are usually there, but the only difference is you are doing them at the virtual layer. You are crossing the virtualization layer and doing. Otherwise, you are actually doing only a network attack. But if you are crossing the virtual machine, VMware or what you call KVM or Zen, which is basically the hypervisor software, then these attacks become virtual attacks or what you call attacks on virtual machines. And hence they are called cloud security attacks. Denial of service attack also there. Attacker can flood with spoof packets to the broadcast address. The sender address is target VM's IP address, providing a service on the cloud, and then the wrong address responds to a particular selected VM. All the packets come to that selected VM. The selected VM doesn't understand how to do it, so it consumes all the resources, so it cannot provide the intended service. The last attack on virtual network is VM sniffing. VMs are connected via virtual switches. Packet sniffing is done at the virtual switch level. So all the VMs share the same hardware resources, and then the attacker can exploit this vulnerability in sniffing the virtual network to gain sensitive information. So these are attacks on virtual network. Then there are typical attacks on virtual machine. They are called VM cross side channel attack, denial of service attack, VM escape, VM information leakage, crawling, malware infection, web attack like cross-site scripting and SQL injection and all that. So those are normal attacks as well. But what is cross side channel attack? Cross VM side channel attack. So the data of time, cache, heat, and power, they are calculated. So using all these data, you can calculate what kind of program is running. So actually, you can extract confidential information. So that is something that you can try to look at, right? So it's called a cross VM side channel attack. So you are not, it's called a side channel because it's not a main channel. What is a main channel? Main channel is the packets, but you are not bothered about the packets. What you are bothered about is what is the cache, what is the heat, what is the power. These are all side. Based on these, you can estimate the kind of programs that are being run. You can estimate whether it is a DES encryption or AES encryption or some of these, because the RAM, the cache, the heat, the movements, the electronic magnetic waves and all. So all these things are calculated, and actually packets are not needed, but then side channels are needed where you can come to this thing. So these are all sort of things that we could simulate and emulate, and we could try that. Guest denial of service attack. A VM can consume all the resources, causing DOS attack to other applications. A very surprising attack, as you see here, is called the VM escape attack. The VM escape attack is an attack in which the attacker gains access to the memory that is beyond the access of a compromised tenant VM. So now what happens? There is a virtual machine. You have compromised the virtual machine. Virtual machine is given, let us say, 1 TB of memory. Now it knows that it is having the 1 TB memory access, so it can go to that 1 memory access. But then you can try to write a code which will try to access memory locations beyond your access. Your access is still, let us say, 1000. You write a code which goes to the location 1004. In that case, what is happening is VM is breaking out of a virtual machine and interacting with the hypervisor and the host operating system. So these are certain things. So from the VM memory, it is going to the VMM memory or the operating system memory, which will cause a lot of issues. So that was what is a VM escape attack. Very interesting attack. VM information leakage attack. This can be caused by VMI functions and access hardware states, system call information or breakpoint injection. Malware infection. Attacker can inject malware in a virtual machine to gain root access. Malware can be worm or can be malicious code injected into the normal program. Attack on web applications which are hosted on this thing. These are attacks on hypervisor, VMM DOS attack or VMM malware injection attack. And here you say the one more interesting attack called hyperjacking. And then you have the backdoor attack, VMM backdoor attack. VMM is another word, virtual machine monitor, another word used for hypervisor. It's a kind of kernel component of the hypervisor. So VMM DOS, resource starvation of RAM, CPU, and bandwidth can cause DOS, resulting in the shutdown of the VM or restart it multiple times. So that is a denial of service attack. Then you have the malware injection. So injected malware can disable or infect critical components like VMM. So that is what is malware injection attack. Then you have the hyperjacking attack. So hyperjacking attack, you install a rogue hypervisor. Rogue hypervisor can take complete control of a server. So hypervisor level rootkits exploit hardware virtualization features. So this is something which is unique. Just imagine what kind of attacks people are trying to do. Hyperjacking. You know what is hijacking, right? Hijacking is taking over an aeroplane. You can hijack an aeroplane. You can hijack a bus or something. You can hijack a car or something. But then here you have hyperjacking. So here you are hijacking the hypervisor. So that's what is called hyperjacking. So what has happened? You are a virtual machine and you have a chance to interact with the hypervisor. But then instead of interacting with the hypervisor, you have a software. You are installing the software on top of the hypervisor. It's called a rogue hypervisor. So on hypervisor, there's another hypervisor running. So this hypervisor takes control of the server. So hypervisor level rootkits exploit the hardware virtualization features and then can create this havoc. And then now the new hypervisor takes over, the rogue hypervisor takes over. And all the virtual machines are talking to the rogue hypervisor. So that is what is called hyperjacking. And just imagine the brilliance of how these attacks can be done. These are all attacks are there. And these papers we have reviewed. We have the survey paper on cloud computing. Highly cited, about 150 citations already reached. So you can look at that. So that is a hyperjacking. And then you have a VMM backdoor attack also. An attacker can take a backdoor entry into hypervisor's privileged domains by overwriting the hypervisor code and manipulating kernel data structures. So that is backdoor, right? So that is one thing you can try to look at. Then there are different attacks on storage, right? Storage attacks, you can look at data leakage attacks, data remnants attack, dumpster diving, and hash value manipulation. Data leakage attacks, basically attacks such as password guessing and dumpster diving can lead to VM data leakage. You can also use keyloggers to gain authentication into target virtual machine and breach its data. So many times dumpster diving is basically like you clean your recycle bin and it is you delete some things and it's still lying in the recycle bin, right? And then you can go and fetch it from the recycle bin. That's what's called dumpster diving, right? And sometimes you can guess a password. You know the user's login. You can try to guess a password. You can use a keylogger and then you can get the password remotely and then log into that system. Second is data remnants. Data remnants is something which you would have come across when your hard disk or computer was spoiled. And then data was corrupted. So you had some important files. So you wanted those files to be extracted. So you went to a shop and then you asked them. So they tried to, draw that and give it to you. So they use specialized hardware and software. And then they collect the data. Even if the system is formatted, you can get back the some of the old data because the file allocation table still remains. The contents are remaining there because it's all ones and zeros. When you delete a file, only the link in the file allocation table is deleted. The entire data is not made zeros. All zeros are all ones, right? So in that case, it all becomes very easy. So if you know, like somebody was using a virtual machine, he finally said, I don't want to use it anymore. So his virtual machine is deleted, but his data remains there only. Next fellow comes in, by that time the data is formatted and given to, but if he's intelligent, what he can try to do? He can try to do some file carving techniques, which people do in computer forensics, right? They do the file carving and then they can dig out this data and bring it out. So many file handling operations, you can get that, and these operations can give you a lot of data, because once data used to be stored, right? So then you talk about dumpster diving, is an attempt to derive information which is declared as waste. It is recorded by attacker that is discarded by cloud user to gain useful information. So that is called dumpster diving. Lastly, you have hash value manipulation. An attacker may manipulate the hash value of the message and can get authorized access to the file stored in the server. So if the manipulated hash value exists in the database, server links to the file to that hash value. If the modified hash value does not exist, server requests a file from the user. So finally, you can actually get the data. Next level attacks are called hardware level attacks. You can have a direct memory access attack, or system management mode attack, SMM, or a BIOS attack, basic input output system. So if physical access to the host machine is obtained, then you can have hardware threats, right? So if somebody is allowed into the lab or into the server room, right, mostly inside employees, once they get access to it, they can do the DMA attack. What is DMA attack? DMA code can be subjected to malware infections to launch stealthy attacks against host kernel by executing on dedicated hardware. An attacker can access cryptographic keys for the hard disk and user sensitive information located in a cache. This can be a DMA attack. Then system management mode, it is a highly privileged mode of the CPU, which deals with system security and power management functions. On insertion of the SMM pin, the CPU saves the entire state in a separate address location called SMRAM. SMM is vulnerable to cache poisoning attack. So cache poisoning, you would have studied DNS cache poisoning you can do, memory cache poisoning you can do. So similarly, SMM, you can do the cache poisoning, which allows an attacker to insert malicious code temporarily in an SMRAM, and because of that, the whole thing gets compromised. The BIOS implements the SMM, and a vulnerability in the BIOS can be used to tamper in the SMM functioning, and allows the attacker to take illegitimate access to system security functions. So these are attacks on hardware. So these are 5 layers of attacks. So I will just give you a brief pause here before I going to take up these things. So maybe virtual machine introspection I'll explain. Maybe if anybody has any questions, I'll be happy to answer. I'll take a water break, then we'll continue further. If you have any questions, you can ask. Because I am taking you through this, I will show you that paper that is based on which we are trying to do all this. So that paper I will show you, and maybe you can try to download it sometime, and then look at it, right? Look at that paper. Just sharing that. Meanwhile, if you have any questions, you can ask.
Good afternoon, sir. Good afternoon, sir. Am I audible, sir?
Otherwise, we'll continue. There is no problem. But in case if you have any questions till here, you can ask.
Hello. 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 Am I audible, sir?
Yeah, this is the paper that I was talking about, about 30 pages. It's there, published in 2017, right? And then it talks about variety of these attacks that we talked about. So the threat model that is there, right? This is the diagram that I shared from here, and these are the variety of attacks. They are explained in detail. Most of these attacks in the papers that these attacks have been discussed are all mentioned here. So if you want to read more about every attack, what are the papers in which these attacks have happened, right? So you can look at that. all the papers that have this thing, and VMI library, different VMI we are going to talk about all of these, some of these tools that can be used. So these are the various analysis that she has done. So accordingly, you could see some of these approaches. Right, about 30 pages, so it takes a long time. So that's why, as I was looking at the attacks also. Right. As you have no questions, we'll continue further. So now you may be wondering, how do I get access to these hypervisor? How do I cross the hypervisor layer? Right. Now I talked about attacks which can happen on the entry level. They are network attacks, because cloud is a network, and the attacks that can happen, they are happening on the network only. So that is a network attack. So, but then when you talk about virtual machine introspection, right? We are actually sitting on the virtual machine and introspecting the virtual machine, what is happening. In fact, one of the things that we try to do as researchers, so many people have done virtual machine introspection. They try to look at a virtual machine and they try to attack the virtual machine. And this virtual machine introspection helped to check the what is happening on the virtual machine. How do you measure some attacks which are happening on an operating system? Because virtual machine is nothing but an operating system, and cloud is nothing but a collection of virtual machines powered by a hypervisor or a virtual machine monitor. So we got hold of this tool called virtual machine introspection. Somebody has done a PhD work on this, and he built a library called libVMI. So what it does is, virtual machine introspection, it can inspect the VM memory and the disk without injecting any agents. The main benefit is to protect the VM monitoring tool from being compromised in the event of a successful security attack, right? So the VM monitoring tool is placed outside of the target VM, but in a trusted VM. So what is this trusted VM? Outside the target VM, the virtual machine is out, but you are putting on a trusted VM. This trusted VM, in the case of Zen hypervisor, is the DOM0. So on DOM0, you place the monitoring tool. The monitoring tool is outside the virtual machine, but all the details of the virtual machine are available in the trusted VM. So that is the basic thing that is there. So this is how the construction of this thing. So this is the untrusted domain. There is a tenant VM, and then you are trying to do. There is this security VM called DOM0, which we said. On DOM0, you set up VMI. And VMI is observing through the hypervisor the other virtual machines. All virtual machines are observed by this DOM0 virtual machine, right? The default virtual machine has got all these information like the guest OS symbol table, the recall profile and all. So this VM can actually check with whatever the information that is stored here, and we can say that there's something is related here, right? So that is how it is. So here we see these are called system calls. When user processes from the user space talk to the kernel space, they are called system calls. But when the system talks with the hypervisor, they are called hypercalls, right? So that is something that you remember. So the virtual machine introspection can actually get you the guest VM's internal behavior, right? Or different state information can be obtained from the hardware, right? So you can also get some information via the hypervisor, right? And then you can get some of these specific Zen hypervisor. You have the Zen control library. So you can get some APIs, and then you can get some more information. What are all the system calls that are happening, you can get. What are the hyper calls that are happening, you can get. All this information you can get. So typical VMI is composed of three main components. As we talked about three main components, the VMI API, and the user space application, the user space VMI application that is there. Where is the VMI user application, right? This is the VMI application, and then you have what is called the guest OS symbol table, which keeps all the symbols that are happening, all the functions that are called, or all the system calls that are called. Everything is available in the guest OS symbol table, right? So these three things is what happens. The VMI application is responsible for the external monitoring of the guest VM, and the application is typically run on a trusted VM, that is DOM0, which has access privileges, which can access the hypervisor specific APIs, right? So user space VMI application uses the functions provided by the VMI API to introspect the various operations of the guest VM. While the application is primarily used to monitor memory events, its functionality can be extended to monitor other aspects of the guest VM, such as network flow and storage activities. The VMI API is installed into the monitoring VM and runs as a library module. It provides an interface between the VMI application and the underlying hypervisor. The user space VMI application obtains different aspects of a VM's state by using the VMI API, which in turn uses the API specific to the virtualization platform on which it runs. So this is the VMI architecture that we are talking about. So the VMI architecture actually really helped, because otherwise there was something which is called a semantic gap, which is the knowledge gap between the internal workings of the guest VM and the low-level information obtained externally. So there was a gap, and only this VMI could use the hypervisor-specific APIs to obtain the information about the guest VM state, and then you could do that. So the VMI software is basically connecting to the or making use of the hypervisor APIs, which are provided by Zen and KVM, and extracting some information, making it available for any tool which can analyze it. So that is what is the VMI. So the VMI implementation typically uses the guest OS kernel, right? Kernel symbol table, the guest OS kernel symbol table called system.map or NTDLL in Windows, and then you can get hold of the low-level state information. It is initialized during the kernel compilation process. The symbol table contains virtual addresses of important kernel data structures, such as the system call table as well as the interrupt descriptor table. Now, what we are trying to do is, let me explain, because cloud security is not network security. Please try to understand that. So if you want to really understand cloud security, you have to go and understand virtualization security or the virtualization software. So anything that crosses the virtualization layer is exactly what we want. So who will give us that? That will be given only by the hypervisor. And who can actually talk to the hypervisor? The VMI can talk to the hypervisor, right? So that is very important. So some of these data structures, like the system call table and the interrupt descriptor table, they are only accessible in high privilege level on the hypervisor. And this is where the VMI tool is able to help. So the kernel symbol table helps narrow this semantic gap that we are talking about to translate the hardware information to the virtual addresses of important guest kernel structure. So we could do that. So hence we came up with this module where we could develop this part. We divided our proposal into 3 parts. We tried to build an intrusion detection system. So one component was running at the virtual machine level. The other component, in fact, there are 2 types. We divided into that, 2 different thought process we had. So we could do a run on the hypervisor. Then the third thing we ran on the hypervisor and also on the what you call the networking server. So this was what was called network level detection, MNPD. This was handling network attacks. This was malware detection systems. 2 different proposals we gave, VMguard and Wade. One was a transaction paper, VMguard was a transaction paper. So we have the similar architecture here, the controller server, the networking server, and the compute servers. You may be wondering, all these are, yes, these are all realities, and these are all can be done, and they were done. And this is 2018 work. So 3 years ago, this work has been completed. So these proposal MSCSD, 1 paper was accepted. VMDS, 2 papers were accepted, VMguard and Wade. And MNPD, another paper was accepted. So if you look at compute server on the virtual machines, MSCSD will run. In the hypervisor, VMDS will run. In the hypervisor, MND will run, and it will also expect on the network server, the MNPD will work. So these are, again, mostly we applied machine learning. So the secret I will tell you here, the secret is, did we set up a cloud? No, we did not set up a cloud. We obviously set up a cloud, but it did not work because it needed a lot of huge computational resources, like multiple cores it needed. If we want to run 10 virtual machines on a cluster of 4 systems, we needed a very powerful switch. We needed a lot of RAM running to 64 GB or something like that. And then we also needed, a lot of these what you call high-speed connectivity. Because of that, because we are not able to give that kind of resources, right, and storage resources also not available, and hence we could not really. We ran the cloud. We understood how the cloud is set up and all, but then we realized that most of the papers were depending on the hypervisor level data, and then again applying machine learning. So here we see mostly machine learning is applied to variety of tasks. So we try to identify the different system calls, traces here. So this malicious system call sequence detection. So once we have some attack system calls collected, the attack system calls are parsed, and then you create a feature vector generate, and then you create a feature matrix log, and then you give to classification algorithms. These classification algorithms will, depending on the learning of the profile, then they will generate the alerts. And then the alert will know. So usually, basically, you have different machine learning algorithms which are executed, and then you get different results. So basically, this is the pre-processing part, and then you have the what is called the compilation part. And this is the diagram, same diagram in a slightly bigger this thing. Another different version you can look at the system call tracing. This is given as input to system call processing, which is given as input, and from there the input is given to a learner profile system, and then finally it is logged out. Right. Second level, we had the attacks which were running, which were at the VMI MD level, virtual machine introspection based malware detection. So I talked about two papers here, VMguard and Wade. So two different techniques here. Again, it was all system call analysis only, but then they were done at the hypervisor layer. The previous one was at the virtual machine layer. If you look at the previous diagram was done at the virtual machine layer. This is the hypervisor layer, and this is the hardware layer, right? So nothing much on the hypervisor layer. Now it is on the hypervisor layer. As you look at it, the virtual machine layer is thin, and the hypervisor is big. So again, the system call sequence is collected, extracted, and all that. So all these things are done, and then you give the input. There are two types of input that you have given. One is called BONG method, bag of n-grams. The other one is a system called directed graph, SCDG. So these two constructions are done. Accordingly, we apply the different algorithms, and then you will get the result, right? So that's what the alerts, and then you are given. So this is what is virtual machine. So here you see this is VMguard, and this is Wade. VMguard uses bag of n-grams, and here it uses system called directed graph. So VMguard is based on system called sequence analysis, and Wade is based on system called transition analysis, right? So that's the difference. So that is where we try to understand. So these are the papers. One is published in IEEE transactions on cloud computing. Of course, now it is online, and then you have concurrency and computation, practice and experience. This is also online. So we have these papers which are readily available. You can go through them and look at, get an idea, and also compare with similar papers which are discussed there. This is the VMguard paper, VMguard's model. This is VAED model. Of course, the same thing that is done. Both are using machine learning. Both are trying to do transient analysis. And lastly, we come to the network layer. So the network layer is where basically we are trying to look at here. This is something here where it is run on the network layer also, and also the hypervisor layer, right? So this is the network layer and the virtualization layer that we have, and we see that the packets are snipped, and then the tracing is done. So detection engine is there. Again, everything is basically machine learning as we try to look at, right? So you have the behavior capturing and traffic validation also, which is done, and the behavior analysis also done. So these things are done, right? So where is MNPD run? MNPD is run on DOM 0, as you see. MNPD is run on networking server, and here it collects different data, here it collects different data, and then keeps the whole mechanism cool, right? So slightly we modified this thing, security model, and we added both at the network layer and at the hypervisor layer, NV Cloud, this thing, and then we came up with PSI NetVisor. So the security model at network and virtual machine layer. This was submitted later, right? So these are the points. So if you have any questions, you can try to look at that. But then before that, before I conclude, I will just briefly give you an introduction to some of the tools that we had used, and these tools are readily available. Only thing is you need nobody's there to help, or there are no tutorials or any of these things to help you. So basically you can read, but then we also, nobody taught us, but they told that there's a tool called Ether, there's a tool called H injector or track move, or these things. And some of the things we observed in paper like Zen Access and Recall, VM Safe, we got in there, right? So Dracov is basically now an agentless dynamic malware analysis system, which is built on Zen, libBMI, and Recalls. And then the dynamic analysis can be done, the linear hardware requirements, rootkits, and all those things, right? Zen Access, basically along with Zen comes Zen Access. So if you're working with KVM, you cannot use Zen Access, but you can, if you are using Zen, then you can use Zen Access. It gives an easy access to DOM view memory from DOM 0 by creating a semantic aware abstraction. Similarly, a series of introspection functions are supported by Zen Access to provide monitoring of DOM view memory. So you can do all these various functions are there, you can use them. libVMI, I have dealt in detail. So you can use libVMI is nothing but VMI. It's basically a C plus Python like binding. You can monitor the low-level details of a running virtual machine. It's called virtual machine introspection. H injector is a tool for injecting hypercall attacks in virtualized environments. You can use that. So you can set up H injector. H injector is a research paper. You can download. Just type H injector and research. You will get this paper, and then you can try to inject hypercalls during regular interaction, and then you can try to see how you can eliminate them by using by saving on those this thing, right? So Ether is malware analysis via hardware virtualization extension. So transparent out of the guest malware analysis based platform based Zen and Intel VT. So that is something you can look at, right? So Recall works with Windows. What Ether and others do in this thing, you can do it. VM Safe is another similar technology, right? So these are the tools that are used. So I stop here, and if any of you have any questions, I'll be very happy to answer your queries. So my own theology, or what do you say, the ideology was cloud is a network. So if you're attacking cloud on the entry level, it is network security. If you want to work on cloud security, you have to cross the network. You have to cross the virtualized network. You have to cross the virtualized compute. You have to cross the virtualized storage. Then only, if you cross the hypervisor layer, then only you are handling what is called cloud security. Otherwise, what you are handling is only a cloud security. It is not. It is only network security, is not cloud security. So it was challenging for my research scholar, and she was finding it very difficult to try to set up VMI, try to set up Zen, KVM, hypervisor, and all these. So it was difficult, but at the end, she has ended up with 5 SCI journals and 5 conference papers, and very good reputed conferences and reputed journals, and then high citation. And finally, she could write a book with Thomson Reuters. She could write the book on cloud security. So that is something that that is there. So if we take up easy problems, right? If we take up easy problems, we are stuck up at that easy problem only. But then, if you are taking difficult problems, if you are taking up challenging issues, then you can look at those things which can become, which will actually give us a different weightage altogether totally. So that is something that I would want to challenge you, and hence don't try to take a shortcut. It's very easy to take a shortcut, but I would suggest that you should take up a slightly difficult problem. And I think this was the book that I wanted to suggest. This was the Cloud Security Attacks, Techniques, Tools. This is the book written by Dr. Preeti Mishra, myself, and Professor R.C. Joshi. Very recently released, 20th December 2021. So you can try to access this. Some chapters are there for display. You have a preview PDF, and then you can try to look at that, right? So these are some achievements, and then the publications also. Most of the publications have reached very good citations because of that. And one transaction paper is a good thing. So the work comprised somewhere around roughly 3.5 years, And of course, it's hard work. And then once you know what you are doing, right, then you can actually facilitate that. So that is something that you can look at. And the challenge is to work with different hypervisors. Presently, also one of the open problem that you can try to look at is hypervisor introspection, right? Virtual machine introspection has been done. You are introspecting virtual machines, but you are sitting on a DOM 0. But now you can sit on a hypervisor itself, and then you can do a introspection of the hypervisor, right? So that is what is called hypervisor introspection. So these are some challenges that you can try to think about. And of course, we did a little bit on cloud forensics, and there are challenges on cloud forensics as well, of how to get data which is already what you call how to collect that data, and how to attack that data that can be done. So that is cloud forensics, right? So both these problems have been completed. And the next challenging aspect is hypervisor forensics. If some of you are interested, you can think of that as a problem. Cloud security presently, looking at compromising KVM is a big challenge, and then you should be able to look at attacks on KVM. KVM is more robust than Zen, I would say, and then it has a slightly different mechanism that it is difficult to handle. So if you can do something on KVM these days, there will be a good response if you would like to look at that part of it, right? So these are the aspects on cloud. Looking at setting up a cloud is very important. A private cloud setup, then only you'll understand where the attacks are happening and how you can try to detect the attacks. And of course, you'll have to read a lot of these literature and papers, so you can try to do that. So as of now, this is what I have. If you have any questions, I'll be happy to answer. Which is more secure, VMware or hypervisor? VMware is also hypervisor, because VMware is proprietary. It is more effective and more secure, I would say, compared to KVM or Zen, which are open source, and hence, of course, open source gives us flexibility to manipulate. VMware gives very less flexibility to. It gives some APIs only, but you don't have that. So that is something that you can look at. So VMware is also hypervisor. Of course, VMware is a slightly different name that is used. vSphere becomes the hypervisor, but actually VMware is generically used, right, to indicate a hypervisor. That was a question by Mr. Rajesh Tiwari. I have answered that. If there are any questions, you can unmute and ask, or you can type. Maybe there was too many things that we have discussed, but what I try to tell you these days is one of the easiest thing that has happened is machine learning to computer science. So what you need to look at is, of course, applying machine learning is not a very good solution, I would say. But then once you identify a concrete problem and you are able to get a similar data set, apply the machine learning. Here, the logic I will tell you, setting up a cloud and collecting attack data on cloud was a very impossible thing. We were trying to do that. We spent about 8 months trying to set up the cloud, attack the cloud, collect data from the cloud, but only very limited data and not so concrete data was obtained. So, but then while we were doing a lot of experiments, I moved into the hypervisor level. Okay, you do experiments on hypervisor layer. So they were doing experiments on hypervisor layer. Some MTech students also joined. Some PhD students also were interested, joined. They all tried to do these experiments. And while they were doing the data collection, they came to know that whatever data was that being generated on the hypervisor is already, there's a similar data set. So we went and obtained the data set and showed similarity between what are the outputs of the VMI and what is the contents of the data set. They both are same. So we said, if this is kind of data that is available to us and we are able to analyze this kind of data, we will be able to analyze this kind of data also. And we have set up a classifier for this. Then we calculated the data. Then slowly we got the results on hypervisor. So most of the data are on hypervisor, because what we claimed is whatever is done on hypervisor can be done on the cloud. And hence, in fact, if you title, most of the work is actually hypervisor security. But whatever happens on the hypervisor is what actually happens on the cloud, because the kernel or the core of the cloud is nothing but hypervisor. Of course, on the cloud management software, some of the attacks can happen. That is a different kind of attacks that can happen. But basically, most of the things are happening at the compute level, at the server level, and at the, at the storage level, and at the network level, which can be handled by the hypervisor. And whatever attacks can be handled the hypervisor is what definitely comprises of cloud security. So you can look at that. Yeah.
Sir, if you put the title of the paper or the link of that paper into the chat box, then it will be more beneficial for the.
Yeah, I will send the paper itself. I will send the paper itself. Anyway, I'm putting the link of that paper. The title of the paper you can get. You can look at my Google Scholar. Definitely, you can get the paper. Right. So I'm putting it here. I'll send you the paper. I'll send you the paper. You can share with the participants. I will send the slides as well. So these two things are there. I have put the title, and it's good, cited well, about 150 citations in last 3 years. And the impact factor is also good. So I was trying to send you the papers, both the papers I will try to send you. Yeah. Yeah, I think there are no questions. So over to Dolly ma'am.
Any more query, please?
Hello, am I audible, ma'am?
Yes, yes, sir.
Yes. Sir, good afternoon.
Yes, yes.
Sir, can we take hypervisor security as the new research work?
Yeah. Yeah, hypervisor security is still open in the sense that hypervisor introspection is an aspect that you can look at. Forensics on hypervisor is also one important challenge that you can look at. So these two, hypervisor forensics, a lot of people are still doing. Hypervisor introspection, HVI, people call it, and people still are working. You can just browse for hypervisor introspection. You'll get a lot of papers in 20 and 21, 2020 and 2021. And then the preferred KVM is the difficult hypervisor. Zen will be easier hypervisor. To start with, you can start with Zen because Zen and Zen server are easier comparatively. You have the DOM0 concept, but DOM0 becomes a kernel in KVM. So KVM is slightly difficult. But then, yeah, start with easy and then end with kernel KVM, which is difficult. Right? So
Sure,
that's
sir. Sure.
something that.
Sure, sir. Thank you, sir.
Right.
Any query? Any more query, please?
Hi. Okay.
Now I think there is no query. So thank you, sir. Thank you.
Thank you, ma'am.
Thank you
Yes.
very much for this very informative and valuable session on
Yes.
this cloud security. Thank you, sir. Thank you so much.
I have sent the material, ma'am, so you can distribute to participants. Thank you.
Thank you, sir. I have put the attendance link in the chat box for today's session. So all the participants are requested to fill the form, Google Sheet. And there is again, I'm again putting a feedback form for the mid session. So I'm putting this form. All please fill the form also, feedback form.